All right, diving into something big here. The Qwen2.5-VL technical report.
From Alibaba Group, yeah.
Yeah, this is not like just a small step forward. This is...
potential paradigm shift.
Yeah, big time.
In how AI understands, interacts with visual information.
The first minute or so, let's give everyone the rundown. The key innovations in Qwen2.5-VL. Imagine AI not just identifying a cat, but like, what's it doing? Where is it?
The context.
Yeah, and even analyzing, like charts, diagrams, multi-page documents.
Like giving AI the ability to see and reason, really, about the world.
Which opens up
so many applications.
Yeah, document analysis, video editing, AI agents interacting with devices.
All sorts of stuff.
We'll unpack it all.
Yeah.
The architecture.
Yeah, we'll dive into that.
Large language model with a super efficient vision encoder.
Then forget the data.
Yeah, massive training data, 4 trillion tokens. Get ready for a model that's matching or even exceeding GPT-4.
It's pretty wild.
Okay, let's get into the nuts and bolts, the architecture first.
The paper breaks down how Qwen2.5-VL integrates a large language model with that highly efficient vision encoder.
Okay.
One of the key innovations, window attention in the vision encoder.
Okay, for our listeners, what is window attention? Why is this a big deal?
So traditional vision transformers, they often struggle with efficiency.
Especially with, like, the big high-res images.
Yeah, exactly, yeah. Window attention solves this by dividing the image into smaller windows, processing them independently. So faster processing without sacrificing detail.
So like breaking a big problem down into smaller chunks.
Exactly.
And that lets it process all that visual data efficiently.
Yeah, crucial for analyzing hours of video or understanding those complex documents.
Okay, speaking of document understanding, the paper highlights Qwen2.5-VL's capabilities.
Document parsing, this is where it shines.
Okay.
Understand complex layouts, extract data from tables, forms, analyze charts and diagrams. It's like OCR, but it understands the meaning in the document.
Okay, so real-world applications, what can we see with this level of document understanding?
The implications are vast. Summarizing research papers, extracting insights from financial reports. Imagine AI understanding your handwritten notes.
That's like a whole nother level.
It is. It's getting close to that omni-document parsing, understanding any document.
Wow.
Yeah, and they've got this diverse range of training data, tables, charts, equations, even music sheets, chemical formulas, standardized. So it's recognizing the text, but the visual structure too.
So it's learning the visual language of documents.
Like a human.
Wow. Okay, so this model, it doesn't stop at static images.
No, it tackles videos too.
Ultra long video.
Ultra long, and not just watching them, it pinpoints events.
With second
level accuracy.
Oh wow, second level accuracy. Even in videos that are hours long.
Yeah, hours long.
How does it get that precise?
So that window attention, we extend that to time. And then there's absolute time encoding. It understands the concept of time.
So not just frames in order.
No, it's like it has an internal clock.
Wow.
Yeah, analyzes the content in a more nuanced way. Summaries, key moments.
Like in a lecture or a sporting event or something.
Exactly, yeah. Complex events over extended periods.
Okay, we've talked about this impressive architecture, the capabilities, but what about the data? What can you tell us about the training data?
Massive. 4 trillion tokens.
Wow, okay.
More than double its predecessor.
Okay.
And it covers everything. Image captions, text paired with images, OCR data, visual knowledge about entities, data for document parsing, video grounding, agent interactions, you name it, it's in there.
So this isn't just random images and text, this is...
Carefully curated.
Okay, so they've gone for quantity and quality.
Absolutely. They filtered out noisy data, used rejection sampling.
What's the rejection sampling?
It's a method where, during training, if the model gets an answer wrong, the data is rejected. Make sure Qwen2.5-VL learns from the best possible examples.
Okay, so it's learning to reason and solve problems effectively.
Yeah, they've gone to great lengths for robustness and accuracy.
Okay, so with all this power, how does Qwen2.5-VL stack up against the competition?
That's the question everyone's asking.
Yeah.
They addressed it in the paper. Compared it to GPT-4o, Claude 3.5 Sonnet, all the big names, across a bunch of benchmarks.
Right.
It's matching or exceeding them.
Whoa.
Especially on tasks needing a deep understanding of text and visual information. Like MMMU, a benchmark testing college-level problems. Qwen2.5-VL got 70.2, comparable to GPT-4o.
Wow, that's amazing.
It is.
Holding its own against one of the most powerful models out there.
Then the smaller versions are outperforming similarly sized competitors, too.
So they've got power and efficiency.
Yeah, crucial for real-world applications, especially on devices with limited power.
Okay, so we've covered a lot. The architecture, document, and video understanding, the massive training data, its performance. But there's so much more. In part 2, we'll delve deeper into those benchmarks, its ability to act as an agent,
Yeah, can't wait for that.
and what this all means for AI. Stay tuned.
It's going to be good. Welcome back to our deep dive into Qwen2.5-VL. Before we go any further, I want to touch on one more thing about the training data.
Oh, okay. What else is there to say about this massive 4 trillion token data set?
Well, they, aside from the size and diversity, the researchers also included a lot of Chinese language data,
Oh, interesting. Okay.
which is different from a lot of other large language models that are mainly trained on English text.
Yeah, for sure.
So,
Why was it important for them to include so much Chinese data?
it's about making sure the model isn't biased toward a single language or culture.
Okay, yeah.
By incorporating a wide range of languages, they're aiming to create a model that's more versatile, can be applied to more tasks and contexts.
That makes sense. It aligns with that, omni-document parsing model.
Exactly. Okay. So now let's shift our focus to Qwen2.5-VL's performance on specific benchmarks,
Okay.
particularly those related to document understanding and OCR.
Yeah, some of its most impressive achievements. I'm eager to hear more about those.
The paper highlights some really remarkable results in these areas.
Okay, so what specific benchmarks did they use? How did Qwen 2.5-VL perform?
They tested the model on a whole range of industry standard benchmarks, including DocVQA, TextVQA, and AI2D,
Okay.
all designed to assess AI's ability to process and understand text within images.
Okay. Can you break down what these benchmarks are actually testing?
Sure. So DocVQA focuses on question answering related to documents.
Okay.
Imagine you've got an invoice or a research paper,
Right.
and you need to extract information from it.
Okay.
DocVQA evaluates how well a model understands the layout, identifies the text elements, and answers questions based on that information.
So it's going beyond simple text extraction.
Exactly.
It's like actual document comprehension.
It is.
Okay.
And then you've got TextVQA
Right.
that tests a model's ability to understand text in the context of an image.
Okay.
So like an image with a street sign that says no parking.
Right.
TextVQA would assess if the model can interpret that and answer questions like, is it allowed to park here?
Okay, so these benchmarks are really pushing the boundaries of what AI can do with visual text.
Yeah. They are, and Q2.5-VL is exceeding expectations.
Really?
Yeah, on DocVQA, Qwen2.5-VL 72B achieved a 96.4% accuracy.
Wow, that's incredibly high.
It is.
Is it surpassing human performance on these tasks?
It's getting close, especially for structured documents.
Wow.
And it's not just accuracy, it's the breadth of its capabilities. It can handle all sorts of document types,
Right.
from simple text to complex layouts with tables, charts, even handwritten elements.
So it really is living up to that omni-document parsing ideal.
It really is.
This brings to mind those diverse training data sets we talked about earlier.
Yeah.
It seems like that approach to data is paying off.
Absolutely. By exposing it to all those documents during training, it can adapt to new, unseen documents.
Okay, that adaptability is crucial for those real-world applications.
Yeah.
Let's talk about Q2.5-VL's OCR capabilities.
Okay.
I know they tested it on benchmarks like OCR Bench and OCR Bench 2.
Yes.
Remind us what these benchmarks are about.
So OCR Bench and OCR Bench V2, they evaluate a model's ability to recognize text in images,
Okay.
but also to understand its context and meaning.
Right.
These benchmarks involve tasks like reading text in complex scenes, understanding document layout, and even answering questions based on the text extracted from an image.
Okay, so not just accurately transcribing characters, it's about extracting information from text in a visual context.
Exactly. And this is where that fusion of the vision encoder and the large language model really shines.
Right.
It can recognize the text and understand the nuances, the relationships, just like a human.
So that's what sets it apart from traditional OCR systems.
Yes. And its performance on these benchmarks speaks for itself. It's significantly outperformed competitors, showing its ability to extract and comprehend text from all sorts of visual sources.
It seems like they've really struck a winning combination with this architecture.
They have.
Now, moving beyond text, what about Qwen 2.5-VL spatial understanding abilities? The paper discusses visual grounding, which sounds pretty sophisticated.
It is.
Can you explain what that is, why it's important for AI models?
Visual grounding links language to specific regions or objects in an image.
Okay.
It's the ability to understand exactly what you're referring to when you use language to describe something visual.
So like, if I ask the model, what color is the car parked next to the tree?
It can identify the car, the tree, and the car's color.
Wow.
Yeah, it's like the AI sees the world through our words.
Okay.
And it goes beyond object recognition. It understands spatial relationships like above, below, next to, and so on.
That's amazing. That kind of spatial understanding is super important for so many applications: robotics, navigation, image captioning, even helping visually impaired individuals.
Exactly.
And how did Qwen2.5-VL do on those benchmarks?
State-of-the-art results on several of them,
Wow.
including RefCoCo, RefCoCo Plus 8, and RefCoCog.
Okay.
These are well-established benchmarks in visual grounding,
Okay.
and its performance shows its ability to link language to visual content.
So they've really bridged that gap between language and vision.
They have, and it's largely because of that careful training data, including examples of visual grounding. So it learns the complex relationships between language and visuals.
It really shows the power of thoughtfully designed training data.
It does.
Okay, so while Qwen2.5-VL has shown all these amazing capabilities, no AI model is perfect.
True.
What are some areas where Qwen2.5-VL still struggles?
So one area is abstract reasoning.
Okay.
It excels at recognizing and understanding visual information, but tasks requiring deeper conceptual thinking, it can struggle.
Can you give me an example of abstract reasoning?
Imagine an image of someone holding an umbrella in the rain.
Okay.
It can identify the person, umbrella, rain, but if you ask why is the person holding the umbrella, it might struggle.
Okay, yeah.
That needs understanding of cause and effect, the purpose of an umbrella, human behavior.
Yeah, abstract reasoning, you have to draw on a wider range of knowledge.
Right, make inferences that go beyond what's in the image.
So Qwen2.5-VL can see the elements, but maybe not the reasons behind them.
Yeah, it sees the pieces, but not the whole picture.
Okay, fascinating. What other limitations do they identify?
Another area is creative content generation.
Okay.
It can understand and respond to prompts with visual info, but it might not generate truly original outputs, like writing a story
Okay.
or composing music inspired by an image.
Yeah, creativity is often seen as like the hallmark of human intelligence.
That is.
So while Qwen2.5-VL can analyze and interpret visual information, it's not the next Picasso.
Right, exactly.
Okay.
But who knows what the future holds?
Yeah.
Maybe models like Qwen2.5-VL will evolve to become more imaginative.
That would be amazing.
Yeah.
Do you think these limitations are just needing more data, more computing power, or are there fundamental challenges?
It's probably both. More data and computing will definitely help.
Yeah.
But there are fundamental challenges in replicating human intelligence, especially abstract reasoning and creativity.
Yeah.
These are complex things we don't fully understand ourselves, so designing AI to match us is tough.
Yeah, we're still in the early stages of AI, but the progress is amazing.
It is, and models like Qwen2.5-VL are pushing the boundaries.
Okay, let's talk about one of the most interesting aspects. Its potential as an AI agent.
Yeah, this is where it gets really exciting.
Yeah, the idea of AI agents interacting with the world, it's been sci-fi for so long.
It has.
But with Qwen2.5-VL, we're seeing it become reality.
We are.
We've talked about understanding UI elements, performing actions on devices.
Yes.
But what have they actually shown us so far?
So they did experiments in virtual and real-world settings.
Right.
They used benchmarks like ScreenSpot, ScreenSpot Pro, and Android World.
Okay.
These involve navigating apps, finding UI elements, executing actions on mobile devices.
So they're not just theorizing, they're testing it.
They are, and the results are promising.
Really?
Yeah, it achieves state-of-the-art performance, showing its ability to operate devices
Wow.
in both simulated and real-world environments. They even showed it working on a real phone, opening apps, scrolling, tapping buttons, all based on language instructions.
That's incredible. It feels like we're stepping into that sci-fi world.
It does.
And the applications, it's mind-blowing.
They're vast.
AI assistants that don't just answer questions, but help us with tasks, scheduling, booking travel, managing finances.
It changes how we interact with tech, making it more intuitive, personalized.
Yeah, more accessible for everyone.
Exactly. And as these models evolve,
Yeah.
we can expect even more sophisticated agent capabilities, blurring the lines between digital and physical even further.
It's exciting and a bit daunting at the same time.
It is.
Okay, let's talk about Qwen2.5-VL's performance on those video understanding and grounding tasks.
Yes. This is where the dynamic resolution and absolute time encoding really shine.
Okay.
They had some great results on benchmarks like video MME, video MMMU, and long video bench, which focuses on, well, long videos.
So we're talking minutes, even hours long.
Yes, and it can understand the content and do fine-grained temporal grounding, pinpointing specific events or actions with second-level accuracy.
That is amazing.
It is.
Can you give us an example?
Imagine you're watching a lecture, hours long.
Right.
And you want to find where the professor explains a concept. You can ask Qwen2.5-VL, when does the professor talk about quantum entanglement? And it'll pinpoint the exact time.
Wow, that's a game changer for students.
It is.
No more scrubbing through hours of video.
Exactly, and it goes beyond education, analyzing security footage, sports, scientific observations.
Yeah, that precise location in time is invaluable.
It is.
And that's where the absolute time encoding comes in.
Exactly, it understands time,
Okay.
processes frames in relation to the actual time, not just sequentially.
So it's like it has that internal clock.
Yeah, it allows for more nuanced understanding of those temporal relationships.
It's not just seeing a bunch of images, it understands the flow of time.
Right, and with that dynamic resolution processing, it can handle all kinds of video formats.
Okay, so they've really pushed the boundaries of video understanding.
They have. Now, one last thing before we wrap up. The emphasis on responsible AI development.
Okay, yeah. It's crucial as these models become more powerful.
It is.
What steps did they take to ensure that?
They made sure the training data was diverse, representative, avoiding overrepresentation. They documented everything, making it transparent.
Okay.
And they talked about the limitations and ethical considerations, advocating for responsible use and further research into mitigating risks.
That's good to hear.
Yeah, it's a trend we're seeing more and more.
Yeah.
This awareness of developing AI for the benefit of everyone.
It's a good note to end this part of our discussion on.
It is.
We've explored its capabilities, limitations, the ethical considerations. In the next part, we'll wrap up by discussing the big picture implications of this research.
Yeah, looking forward to that.
Welcome back to our final part, our deep dive into Qwen2.5-VL. We've covered a lot: the architecture, the performance, the potential, even ethical considerations. So, what are your final thoughts on this research and what it means for AI?
It's been amazing exploring this model. Qwen2.5-VL, it really is a paradigm shift in vision language AI. It's not just recognizing stuff, it's understanding it. Images, videos, at their native resolutions, documents, grounding, even acting as an agent.
And it does all that while being so efficient, thanks to those innovations, window attention, and dynamic resolution processing. It's powerful, scalable, adaptable. It could really change so many industries.
You said it perfectly. The potential is huge. Document analysis, automating tasks, summarizing research, extracting insights, even translations. Video editing, imagine searching, editing, analyzing video in a whole new way. And accessibility, helping visually impaired people understand their surroundings, navigating digital interfaces.
And we can't forget about its potential as an AI agent. It could completely change how we interact with technology, make it more intuitive, personalized, accessible.
Exactly. And as this tech keeps getting better, we might even see AI agents doing more complex things like helping with medical diagnoses, personalized education, even creating art and entertainment.
It's a future full of possibilities, but also some ethical things to think about.
That's true. As we develop these powerful systems, we have to be careful, thoughtful, responsible, make sure they're used for good, benefit everyone, and we got to address any potential risks head on.
I'm glad to see the researchers behind Qwen2.5-VL are taking those ethical concerns seriously, focusing on data diversity, transparency, responsible use. It's a good example for others.
It is, and it's becoming more common, which is good. There's more awareness of needing to develop AI in a way that's good for everyone.
So where do you see this tech going in the next few years? What's your prediction for the future of these vision language models?
I think we'll see them getting even better, more efficient. New architectures, training techniques, better data, models that understand even more, reason better, interact with the world in new ways.
So better performance, tackling more complex tasks, AI becoming even more integrated into our lives.
Exactly. And I think we'll see more specialization. We'll have general models like Qwen2.5-VL, but also models specifically for healthcare, finance, education, even art.
That makes sense. Specialized models could be even better for specific things.
Right. And that specialization will lead to a whole bunch of new AI tools and apps, each one solving specific problems.
So the future of vision language AI is looking pretty bright, changing how we live, work, interact with the world.
I agree. It's an exciting time to be working in this field. I can't wait to see what the next few years bring.
It's been great exploring this with you. Thanks for joining us for this deep dive. We hope you found it interesting and thought-provoking.
It was my pleasure.
And to all our listeners, keep exploring this amazing world of AI. You never know what incredible discoveries are just around the corner. Until next time.